Alright, here we go with objective 62, which is factoring difference of squares. This is going to be our last objective for the unit that talks about factoring, and then we'll move on to solving. So here, let's start off with a review. Here we have a plus 4 times a minus 4. We've got two binomials. In order to multiply these, we're going to use, again, our FOIL method. So this is first, outer, inner, last. We multiply the first terms. We have a times a is a squared. Outer terms, so negative 4 times a is negative 4a. Our inner terms, positive 4 times a gives us a positive 4a. And our last terms, we have a positive 4 times a negative 4 gives us a negative 16. We combine like terms. I have a negative 4a and a positive 4a. Those cancel. So all that's left is a squared minus 16. Next up, we have c plus 9 times c minus 9. So first, outer, inner, last. C times c is c squared. Outer is negative 9c. Inner is positive 9c. And last, we have negative 81. Again, we combine like terms. Negative 9c and a positive 9c cancel. So we have c squared and then a minus 81. Let's do one more. Here we have 2x minus 5, 2x plus 5 first. So again, numbers with numbers, variables with variables. So 2 times 2 is 4. X times x is x squared. Outer, we have 5 times 2x. We multiply the numbers, so we have 10x. Inner, we have negative 5 times 2 is negative 10x. And last, we've got negative 5 times 5 is negative 25. You may already recognize the pattern. We have a positive 10x and a negative 10x cancels, so we have a 4x squared minus 25. All right. So again, today we're talking about factoring. We want to go from here to here. What you may notice here is we've got a quadratic, right? This is a c squared. The degree is 2. The general form for a quadratic, as you remember, is ax squared plus bx plus c. But these aren't in that form. We don't have an x term. We just have an x squared term, and we have just a number at the end. So we have ax squared plus c, just an x squared and a number. Something you might also notice is that we have a squared and 16. 16 is a perfect square. Or we have c squared minus 81. 81 is a perfect square. Right? And then we've got 4x squared minus 25. 25 is a perfect square. And in fact, we've got x squared, c squared, a squared. Those are all perfect squares as well. So today we're talking about factoring a difference of squares. So an example is something like this here. We have x squared minus 36. How can we recognize this? This is when you are missing the middle term. So just like how we had above, we're missing that middle term, that x term of the quadratic expression. Something else, this is also when the first and last terms are perfect squares. So the first and last terms are the ax squared and the c. So if ax squared and c are perfect squares, then we can use this difference of squares. Okay. Also, if they're separated by subtraction. So this only works when they're separated by subtraction. That comes from, it's a difference of squares, so subtraction. So looking at this here, we can always rewrite this using that middle term. So if we were to rewrite this and say this is x squared, well, our middle term, we don't have one, so we could say it's plus 0x minus 36. And this we know how to factor. We can say that, well, what are the factors of 36? What two numbers multiply to get to 36? We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, and that's it. And the next step says what two terms, or what two factors, what pair adds up to get to 0, that middle term. So 1 and 36, no, that's not going to add up. That one's not. That one's not. But 6 and 6, you can add those up and get to 0. You can take a positive 6 and a negative 6. So if we were to factor this, this would be x plus 6 and x minus 6. So there are two options when factoring. So that's option 1, what we just did. So option 1 is we can replace the middle term with 0x and factor as usual. So that's exactly what we did up here. We replaced the middle term with 0x, and then we just factored it as normal. Option 2, which I prefer option 2, I think it's a little bit easier. The general form for a difference of squares is a squared minus b squared. So here we have a square, so a squared. We have b squared, so these are both squares, and we're taking the difference, we're subtracting. This factors as a plus b, a minus b. Right, if you were to FOIL this out, you would find that this equals a squared minus b squared. So let's go ahead and try this example again. We've got x squared minus 36. You might recognize that, well, x squared is a perfect square. We can square root that. 36 is also a perfect square. We can square root that. And it's separated by subtraction. So we have a difference of squares. So when finding this, we can take our first term, take the square root, and take the second term, the last term, and take the square root. So the square root of x squared is just x. The square root of 36 is 6. So we can take x plus 6 and then x minus 6. And you can see that that gives us the same solution. Let's try some. So here we have a squared minus 9. Now you could substitute in a 0x for that middle term, that missing middle term, and then factor as normal. But let's try the second option. Here we have a squared minus 9. We can take a squared, square root that, and that gives us just our a. We can take our 9, square root that, and the square root of 9 is 3. So then we have a plus 3 and a minus 3. So again, 1 is always plus, 1 is always minus. Let's try example B. So we have b squared minus 4. We can take the square root of b squared. Our square and square root cancel. They're inverses of one another. So the square root of b squared is just b. And then we have 4. The square root of 4 gives us 2. So we have b plus 2 and b minus 2. Next up, we've got 9d squared minus 49. Now this looks a little bit more challenging, but it's not all that different. Let's take that first term, 9d squared. Let's find the square root. Well, remembering what we learned in our radicals unit, we can split this up into the square root of 9 times the square root of d squared. Well, we know what the square root of 9 is. The square root of 9 is 3, and the square root of d squared is just d. And then our last term, we have 49. We take the square root, and we get 7. So then we have 3d minus 7 and 3d plus 7. All right, this last one, we have 16 and e squared, so we can take the square root. The square root of 16 is 4. The square root of e squared is e. Now, take note which one comes first in the expression, the number or the variable. In this case, the number comes first. So when we're writing out our two binomials, our two factors, we have to write the number first. So 4 plus e and 4 minus e. In all of the other examples, our variables came first. So like in this one, we have our d's and then minus the numbers. So when we're writing out our binomial, we also have to write it in the same way. So our d's come first and then the numbers. In this case, the numbers first and then the variable. So our binomials, our factors, have to be the numbers and then the variable. All right. This is Objective 62, difference of squares.